Hi everybody, today we're going to talk about net forces of vectors. A force is simply a push or a pull on an object. When we think of force, we think of both the magnitude of the force and the direction that the force is coming from. Let's look at a quick example. Let's say we had two people standing 10 units apart playing tug-of-war. If they both apply the same force, then we'll see that the net force is 0. But if one person pulls harder than the other, we'll see that the resultant force is the sum of the two forces. So it might move to the right, or it might move to the left depending on who's pulling the hardest on the rope. The units used for force are called newtons. We won't get into the details of the measurement, but it's basically the amount of force needed to move 1 kilogram of mass 1 meter per second squared. Notice this is a unit of mass times acceleration. The net force is going to be the sum of the forces acting on an object. Remember as you find the sum that the result will have both a magnitude and a direction. For example, what if we have a person pushing with a force of 12 newtons on a box? If we need more force, we can add a second person that also pushes with 12 newtons of force. The resultant force will be the sum of the 12 newtons plus 12 newtons, which is 24 newtons, and because they're both pushing in the same direction to the right, the resultant force will go to the right. Let's try another example where we take the box and this time it's suspended off chains. If the chains are pulling up with a force of 12 newtons, but the box is being pulled down by gravity with a force of 18 newtons, let's find the resultant force. We can think of the 12 going up as positive, the 18 going down as negative, which says the overall force is negative 6 newtons. The negative force says our box is going to fall. Let's find the magnitude and direction of the resultant force, where we're going 7 newtons to the right and 11 newtons up. Remember that when you add the vectors, you want to add them head to tail. Our resultant force will be the hypotenuse of the triangle that these two sides form. We can see it goes up and to the right. To find the magnitude, we need to find the hypotenuse of this triangle. We'll take the square root of 7 squared plus 11 squared. That's the square root of 49 plus 121, which is the square root of 170. Let's find the magnitude and direction of the resultant force, where we have 18 newtons pushing down and 10 newtons pushing to the left. Adding the vectors head to tail, we can see that our resultant vector goes down and to the left. To find the magnitude of the resultant force, we find the square root of 18 squared plus 10 squared. That gives us the square root of 324 plus 100, which is the square root of 424.